Hello there. From this day we are going to start a tutorial on DLD. Now if you guys are familiar with DLD, or if you are doing some fundamental course or if you're attempting some certification course for computer science, then you might be familiar with the term DLD. This is actually a core course for computer science students. Now they need to pass this exam to complete any certification in computers. I'm not talking about basic computers, I'm talking about some sophisticated degree of computer or discipline of computer science. So without further ado, let's start our first class. In the first class we are going to learn what DLD is and what course content or outline we are going to be covering in this course, in this playlist. So first of all, DLD means digital logic design. Now there are some terms in the name too, but we are going to understand them with the passage of time as we go along with the course. Now first of all, why do we study DLD and what do we study inside the course of DLD? So the basic purpose of studying DLD is to understand and design the digital circuits. There is a main thing here that I have underlined here. This is the main thing that we will be discussing in all our course. So what is the purpose of DLD? In DLD we basically try to understand and design these digital circuits. Now you might be familiar with the word circuits. This is a word from physics, which is simply a network of different electrical components. But as we are using computers and as the word digital is also here, so here we will be talking about electronical components too. So these circuits may also contain some electronical components apart from the electrical components. So we are going to be studying about digital circuits. We will see how these are created, how these are designed, and how they work. Now why am I creating or designing digital circuits? To perform some specific function. I want them to do something for me. Let's say if I want to do addition of two numbers, I will create a digital circuit for them. Similarly, if I want to multiply or divide two or three numbers, I would create a digital circuits for them. So that is why in the background of computer these digital circuits are working. Actually these are abstract, but these are working in the background. So we are going to understand and design these things here. Now digital circuits have a property or a nature that they only operate on digital signals. As we are talking about digital circuits, so this means that we are going to be dealing with digital signals only. Normally these are considered as 0 and 1. In physics people call them low and high, and we will also discuss these things in the coming lectures. What are 0 and 1 and why do we frequently use them in DLD in computers. Now this is just a basic introduction about DLD or digital logic design. Now what are we going to be studying in this playlist? So the course overview that I'm going to follow is going to be something like this. First of all, we are going to be studying the binary systems. In this chapter we will try to cover all the number systems that are available in computer science, their application, their uses, their conversions. I'll try to cover everything then here. Then we will discuss some gates here. Now again, if you are familiar with physics or electronics in physics, there were some gates like AND or NOT and some other gates that we can create by the combination of these gates. So here we are going to study those. Then we have Boolean algebra. Now this is a computer specific term or algebra where we deal only with 0 and 1. We are going to be discuss all of these things. We're going to be discussing all of these things. Then we can also use these logic gates, and we can implement this Boolean algebra on them, and we can create some combinational logic circuits. Then we are going to use some simplification methods like Karnaugh map and these other methods that we have. And apart from these, there are also some other methods that we're going to be discussing in the future. Then we have MSI and PLD components. I don't want to define them right now because I am just trying to make you guys understand what are we going to discuss in the future. So basically here we are going to discuss how numbers are added, how multiplexing, demultiplexing is working in the background. We will come to this in the future. And then we will we are going to be focusing on sequential logic, we are going to be focusing on synchronous sequential logic and asynchronous sequential logic. We will also discuss registers and the counter registers, or the counters, or the memories that are using these electronical components. Like if we talk about ROM, if we talk about CMOS, these are using these electronic components. If we talk about our cache, which is our SRAM or static RAM, these are actually using electronical components. So we will be discussing these things in this chapter. Then we will also discuss, we will try to discuss the integrated circuits that we have been studying from the history, that transistors combined together to create integrated circuits. So we will also discuss these things. Then at the end of our course, we are going to be learning a language that is called as hardware control language. Now hardware control language is actually simply a programmatical representations of these logical circuits. If we have some logical circuit, we can create some programs for them using this HCL, or hardware control language. So this course is going to take some time, as I'm trying to create 1 or 2 videos. I'll try to create a couple of videos per day, and I'll try to upload them as soon as possible. And the book that I'm going to follow to complete this course is a book written by Mano, and the book is named as Digital Logic and Computer Design. You can find this book from any web page on Google in PDF form, or you can also order it from Amazon if you want to read physical form of this book. But I've seen this book, I've studied this book, and it is quite understandable, especially for beginners and students. So I would recommend you guys to study this book, and I'll also try to follow this book throughout this course. So this was our first class. This was our orientation introduction class to DLD. In the next class we will formally start our course. Thank you.